Hello students, in last session we discussed about what is chemical bonding, types of chemical bonding. We talk about much detail in ionic and covalent bonding. Now in this is the second session and this is the last session of the chemical bonding chapter. So here we're going to talk about these things. So what are the objective of this session? So here we're going to talk about the objective of this session. We're going to talk about the octet, what is octet, what is duplet. Then we're going to talk about the coordinate covalent bond and the formation of ions. So here we're going to talk about this much in this whole session. So let's begin with our session with a great enthusiasm. Okay, so see, whatever we have learned in the last session, we are going to connect those links to this session as well. So it is very, very important. Okay, so let's move further. See, we have learned about the octet and duplet, correct? So what is exactly the duplet? The hydrogen atom and the helium atom are the smallest element in the nature and have only one orbital around their nucleus. This orbital is called a 1s orbital, or we can say first orbit. This orbital can contain a maximum of 2 electrons. So accommodation of how many electrons can be there? 2 electrons. Hydrogen atom has 1 electron and the helium has 2 electrons. In case of hydrogen, only 1 electron is there. It's a uni electron. Then in case of helium, there are 2 electrons. So hence helium is called a duplet because how many maximum number of electron can be accommodated in the last cell? 2, and that's why it's a stable. See, it's a follow under the category of the noble gases, and we know that in a whole periodic table, the one which is at the group 18, that is the noble gas, or we can say inert gases, they actually the stable, and every element in the whole periodic table try to be or mimic the electronic configuration according to that. So that's why there is a rule of duplet and octet. Okay, so helium has a maximum number of electron that can be had. Thus, it is a stable element in the nature. Therefore, helium is an inert gas, but the hydrogen, in the case of hydrogen, has only one electron. So he is not stable right now because he has to be required one electron to get stable, and that is why its orbit it has incomplete. Okay, have you got the point? So what is a duplet and what is the impact of the duplet? Thus, hydrogen atom alone is a very reactive and it tends to form a covalent bonding. Covalent bond with the another hydrogen atom by the sharing the only electron they have. Then these hydrogen atoms become a duplet as they now have 2 electrons in their outermost orbits. But in case of lithium, when you talk about the lithium molecule, we know that there are 3 electrons. Correct. So in the first orbit, 2 electrons can be accommodated and the only one is remaining. So it is follow the duplet or octet rule. Let's see. But the lithium can behave as a duplet by removing the 1 electron from its outermost shell. So lithium is very smart in this case. It's remove the electron. What are the outermost? So remaining what? 2 electron. Now is so the electron of lithium is a 1s2, that is in first orbit there are 2 electrons, 2s1 in the second orbit there are 1 electron. By removing the 2s1 electron, it can be become a duplet. In case helium, hydrogen, lithium plus C, hydrogen minus and lithium plus are duplets that can exist as a stable duplet. So what are the duplet present? Helium, we know that. Hydrogen minus means what? Only one electron is there, or it will be gain the electron and it will become 2 electron, and that is by after gaining the electron it acquires a negative charge. Lithium, by removing or by losing the electron, it's acquire a positive charge. This is how it works. Now what is octet? An octet is an atom or an ion having the 8 electron in the outermost shell of the atom. All the noble gases except the helium have a 8 electrons and are inert in nature. The electron configuration of the noble gas will always end as follow: Ns2, Np6. What is that? Ns2 and Np6. So this is how the octet rule works. Now, for example, the electron configuration of a neon is 1s2, 2s2, 2p6. See students, this is very easy. Don't get confused with what is 1s2, 2s2. 1s2, S means first orbit, P means p orbit, or after s orbit, p orbit comes. In case of S, only 2 electrons can be maximum number of accommodation is 2 in S orbit. In P, maximum number of 6. Okay, so up till now you have to understand this. So please pay attention. In case of neon is an inert gas. Other elements having the 7, 6, etc. If suppose element having a 7 or 6 electron, what happened with this? So let's study that. Electrons in the outermost orbit, even see my cursor, right? Orbit tends to obey octet rule by opting the electron from the outside. In case of 7, let's talk example of fluorine. It has a 7 electron in the outer. It will not lose all the 7 electron. It will be gain 1 electron. Okay, and some other elements having the 1 or 2. See, if the less than 5, they can lose. So there is a category of metal which has the tendency to lose the electron. But if more than 7 is point. So it's like a, yes, it's like a what? It's like a gain electron, and that is mostly not. But other elements in the middle of the periodic table will form new bonds with the elements having the excess electron to share those electrons and become an octet. Now, exactly what is octet rule, and this is very, very important. See, duplicate will follow by the three ones, which are the atoms that participate in bonding share electrons in the way that enables them to acquire stability. So whatever this is going on, this is for the stability purpose. Losing or gaining of electron is to get the stable electronic configuration. Electronic configuration or this means that they want to acquire electronic configuration. Obviously, the name of this rule is a misnomer. Helium, noble gas of the first row, has only 2 electrons. Hydrogen, the only element in the first row, basically is sharing electron only. So according to the two phenomena, octet and the duplet. Okay, getting my point. So what is the importance? So every element in the periodic table try to mimic the electronic configuration as same as the noble gases. Correct, because noble gas has 8 electrons in the outermost shell and they are stable. So that's why every element want to be stable. For that purpose, it accepts or lose the electron according to the number of electrons present in the last shell. Now, electron dot structure. This is very, very important point we are going to talk. Electron dot structure is helpful tool in thinking about the bonding. In earlier previous class, we have studied about it, but here we're going to talk in much detail manner. Pictorial representation of the valence electron configuration around an atom. It gives the valence shell. It's not going to talk about all the electrons. It's going to talk about only the electron present in the valence shell. We will only talk about the main group and mainly only be concerned with the sp orbit. So here in your syllabus, you're going to stuck with the s and p orbit only. Let's talk about carbon. You can hear 1s2s2 to 6. Tell me one thing. What is the atomic number of carbon? 6. Correct. In first orbit, how many electron can accommodate 2? So that is 1 s 2. In second, 2 electron. That's why 2. In p, how many electron can maximum is a 6. But what is the remaining around? Only 2. So it is electronic configuration of as 1s2, 2s2, 2p2. That is 4 valence electrons. In last shell, second is the last shell. Correct. Getting my point. So in last shell, how many electrons are there? 2 plus 2, 4. So carbon valence is count as a 4 one. See, we have seen in the atom structure of the electrons, but here we are going to talk about the electron configuration. Okay. See here, you can see carbon has a plus 6 positive charge. Electron here are 2. After that, 4 electrons are there. Electron dot structure. Let's talk about it in manner. Valence electrons are represented by the dot placed around the symbol. Electrons are placed up 2 on each side of the elemental symbol for maximum 8, which is the number of electrons in a filled S and P shell. We place a single electron on each side before pairing them up. This is related to the Hertz rule. This is Hertz rule actually. Period 1, that is hydrogen and helium, the exception that only the maximum of 2 electrons are placed on one side of element. Why this is so? We just have discussed about that. That is a duplet rule. Electron dot structure related to their group number, and this electron dot structure for the first 2 periods. Number is equal to what? Valence electron related to group number. So we have to understand this. So here is the interpretation of this. So how you interpret this? In case of hydrogen helium, we know that they follow the duplet rule for the last sentence. Electron dot structure for the one and 2. What is the number of valence electron? Number of valence electron related to number. So group. That means the electron are 2. You can put it there. Valence electron carbon. 5 in nitrogen. Getting my point. So this is how we have to interpret. Now, covalent bond, that is the sharing of electrons, unlike ionic compounds where electrons are thought of being gained or lost. We understand covalent bonding, sharing of it may be loose or it may be gained. So there is an exchange of the electrons among the atoms of the bonds. Okay. Now, compounds with the metals, non-metals generally gain an electron and become negatively charged. Compounds with the other non-metals, valence electron are generally shared to the achieve filled valence shell. Sharing electrons. Covalent bonding, that is the sharing of electrons, is the glue that binds atoms together. This is how we have to interpret. So now, example. This is very important. Please students pay attention to this. In case of hydrogen is represented dot, another hydrogen is represented cross. I mean the electron gamma. When they combine, they will share two electrons per bond H bond H. So sometimes you can use the dot to represent. So this is a sequence. It tells you that electron dot structure, correct? But you have to use cross. No, according to that, if the two hydrogen distinct, you have to show that. So you can use dot. You can use cross. Depends on you. Because see, now here the important is a helpful tool in thinking about the bonding, and it's give the pictorial representation of the valence electron. That is why it's quite important. Okay, let's move to chlorine. See, in case of chlorine, the chlorine is showing this electron. I will go slow. Okay, don't worry about it. Just to understand and to convert. Here, the chlorine dot are there, 7s are there, include, but whenever they combine, you can see also this chlorine. See, count the chlorine electron. Dot how many? 1, 2, 3, 4, 5, 6, 7, 8. Because across 8 will become 10 cross, 8 to acquire octet. Getting my that's why share. It is balance. So see, now this is a dot over here. It is a cross over here. If you are comfortable, you line, that line is the exchange of the electron from from the chlorine, from this chlorine, and if you go in very specific manner, you can only draw this line and indicate this way. So this is how you chlorine. Just have a look, student, over here. Okay. Shall I move further? Yes, definitely. Okay, let's move further. Now, octet rule for S and P elements only, and combine and forms a bond either transferring electrons and by sharing bonds. The bonds are considering in the counting the electrons in both atoms involved in the bonds H and the helium. Now, in case of, see, we have studied that again, those points are repeating. Okay. Now, it's in case of H2O. See, one hydrogen is here, one hydrogen is here. They're going to donate one electron. Combine. Do you find this structure? Just this electron. See, you can see my cursor, right? This electron and this. They're going to combine this. So, ultimate third structure is very important. Just have a look on the student. Yeah, correct. Okay. Chalo, let's move further. Now, in case the thing we have to talk about electron dots are very precise because they are going to talk on the valence shell or valence electron. But as we move further in this case, see a pictorial representation of the whole atom. It's quite difficult to draw all the structure. It's quite easy in case of water, but if you move further for different molecules or the chemical formula, it will be difficult to draw all the structures. So electron dot structure is quite easy and widely accepted. See, I'm going to talk electron, they're donated, they add oxygen, and the oxygen, like, count. See, count the oxygen electron, last shell, see, count first rate, 1, 2, 3, 4, 5, 6, and now blue, 6 plus 2, 8. So that's complete the octet. In case of hydrogen, count blue plus for first blue, there will be 1, then they call duplet. So actually, the shell electrons, and they completed their duplet. Have we got the point? How they smart are? Okay. Now, let's move further. How would you put together nitrogen and hydrogen to form a compound? Yes, we're going to talk about the ammonia, that is NH3. So how can you put that C? The bonding pair. See, you can say hydrogen, three hydrogens are there and one nitrogen is there. So it's a representation of that. Correct. You're going to bond, but nitrogen have a lone pair, one lone pair of electron. In case of oxygen, two lone pairs. In case of nitrogen, only one lone pair is there. So that's why if you ignore the lone pair, how many are there? 1, 2, 3, 4, 5, 6. But lone pair has to count, and that is why 8. So duplet octet is completed by the nitrogen, and duplet is completed by the nitrogen. The state, students. Yes. So there is a bond pair and there is a lone pair. Can anybody tell me what is a lone pair? Yes, lone pair is called also extra pair. Correct. Okay. See, now I'm assuming I'm interacting with you because whatever the question in your mind, I want to resolve it. That's why I'm just trying to interact in both way. Okay. Let's go out and let's talk about methane. Then you talk about the ammonia. Now let's talk about the complexity is increasing. Right now we just talk about the hydrogen. It's quite easy. Water is quite easy. Ammonia is quite easy. But right now we're moving to the much more complex things. So it is very easy to draw an electron dot structure instead of whole atom structures. Okay, so in case of methane, yes. Let me make sense. So this is the whole electron. This is one they form this structure. So this bottom yes, it's also electron dot structure. The formula of the carbon right now H4 be done now CCl4. Its electron dot structure is that. Okay, just think how can be the structure will be. Yeah, structure like this. This is like you draw it. The electron structure put it into the cell and like one line. So it's quite easy. So chlorine share one electron to complete this octet. Carbon is going to share the 4. That is carbon tetra means what 4. Comparison of electrovalent and a covalent compound. We're going to talk about the comparison of electrovalent and covalent. See, electrovalent compound are not covalent. Electrovalent compound good conductor of the heat and covalent compound is bad conductor of it. Can anybody tell me why this? Yes, electron compounds were good conductor because they have ability to donate again electron very fast or very easily. So that's why they conduct the electricity. Okay, see electron, electricity. Correlation is there. Now covalent compound, in case of they have strong, so electrons are shared, paired. So the problem is that they are not moving as compared to electrovalent. So they are bad conductor. Now, electrovalent compounds are soluble in water and insoluble in organic solvent, whereas covalent compounds are insoluble in water and soluble in an organic solvent. Electrovalent compounds have a high melting and a boiling point, whereas covalent compounds have a low melting and a boiling point. An ionic bond is formed by the transfer of valence electron from one atom to the another. A covalent bond is formed by the mutual electron between the pairs of atoms of a non-metallic element. There is one more type of chemical bond called a coordinate covalent bonding. So what is that? Let's study about this. I hope you understand this slide. I'm just going to wait for 2 seconds to just go through this. And this is very, very important points. Okay. Now let's talk about the coordinate covalent bond. Here it is a very interesting topic. A coordinate bond is formed by a shared pair of electrons with both the electrons coming from the same atom. In other words, one of the combined atoms will share there is one donor. In case of sodium and chlorine, we have just discussed in earlier class. Sodium going to donate electron, it is act like an electron donor. Chlorine will be accept, it act like an electron acceptor, electron gainer. Same with the atom that with the 2 electrons is known as a donor. The atom or a group of acceptors. See here the word is 2. I mean you have to number, you have to understand number is 2. That is 2 electron has to be donate, 2 electron has to be accept. Then only it's considered as a coordinate covalent bonding. The bond formed between sharing a pair electron provided entirely by one of the 9 atoms but shared by both is called a covalent bond. One is going to donate, one is going to accept. And this bond, but both of the atoms going to share it. It's called coordinate bond. The one which is blue arrow is going to indicate. Okay. Condition for the formation of covalent bond. What is the first? One of the 2 atoms must have one lone pair of electron. Here the points come. We talk about lone pair of electron. We have seen in case of oxygen 2 lone pair of electron. In case of nitrogen, 1 lone pair of electron is there. So this is the condition, that is that it must contain a lone pair of electron. Second condition is what? Another atom should be the short or at least lone pair of electron. Okay. So these are the conditions. Just have a look over here. Here it is actually representation. Coordinate arrow, the tail indicate the donor and the head indicate the acceptor of the electron pair in the bond formation. This bond formation works here. That is one donor, one acceptor is here. Point. So donor with electron goes to the acceptor. The compound coordinate compound bonds. Formation of the hydronium ion, it is can be represented as H3O plus. What do you mean by hydronium? You have water. Yes, what are the oxygen, which is the lone pair. So we have seen in our last or previous class about the hydrogen bonding. Yes, the same going to be this. What form by the mutual electron between the oxygen atom and the 2 hydrogen atom, which result in 2 single covalent. Your oxygen atom 2 electron after the octet configuration. This is a point to understand. So in this case, see in this case, let's come back to the point. Lone pair of electron. When you talk about the lone pair of electron, see here oxygen has a 2 lone pair of electron. It's already the electron is got shared with the hydrogen. Hydrogen are very satisfied. They're done with the duplet rule, so they are not going to interfere with the lone pair of electron. Now there is an interaction of lone pair of electron with another hydrogen. So what is that? See here, the hydrogen ion is formed when a water molecule bonds with a hydronium ion. A hydrogen ion is formed by the loss of one electron and becomes H plus. Thus, it needs 2 more electrons to get a stable duplet configuration. Obviously, when a water molecule and the hydrogen ion approaches each other, the hydrogen ion accepts the lone pair of electron. Who's accept? Hydrogen ion. Yes. From the oxygen from the water molecule, which result in the formation of coordinate bond. So, have you got the point? Oxygen donate the electron towards the hydrogen, there is a formation of bond. Thus, by sharing the 2 electrons from the oxygen, the hydrogen ion gets a stable duplet configuration. See here, this is how happens. See, water is a stable, but because of the lone pair of electron contained or possessed by the oxygen in the water molecule, it's also going to share with what? Another hydrogen, and there is a formation of hydronium ion. What is the name? Hydronium ion, student. Okay. This is the actual representation. Okay, the one electron is donated with the hydrogen, and that hydrogen now form a bond like this. Okay, so formation of ammonia ion. Now let's talk about the ammonia, that is NH3. But here ammonium ion is there. What is the ammonium ion? NH4. The formula of ammonium ion is NH4 plus. Means what? NH3 more ammonia. So one hydrogen is got into incorporated to the reaction, or sorry, it was structure because of lone pair of electron. Whose lone pair of electron? Hydrogen. How many there? One lone pair of electron. Bond between an ammonia and hydrogen ion. In ammonia, 3 hydrogen ion form a 3 single bond with a nitrogen. Here hydrogen atom has a one lone pair of electron. Now, when ammonia is dissolved in the water, it forms a ammonium ion. and the hydrogen from that, what going to happen? Let's see. Thus, in this diagram, and to say this ammonia, what molecules get incorporated, there is one hydrogen is added because there is a lone pair electron of the hydrogen hydrogen by a positive charge. Why positive charge? Earlier is a negative charge to the lone pair electron, but right now those are shared with the hydrogen. Now there is a duplet configuration completed with the hydrogen and this positive. Now formation of NH3 and BH3. Then I will go here. Look, okay, look, okay. The bond formed between ammonia and boron sulfur. Try to write up point T is not so here. Try here. Okay, what are we look at the bond. Then also what between nitrogen, boron, positive and neutral. This is how the reactivity works. Is formation of ammonia and boron atom. So the active one is active one, but when the front atom, whatever the individual atom is there, is going to accept it. Only it would active and into boron is active. So the electron get by nitrogen. That is look at it's formed between nitrogen and boron. Okay. So here we finish this whole chapter. I hope you understand all the things. Okay. So just give me 1 second. Yes, students. So we have done with this chapter, that is chemical bonding. We have talked about the octet rule, duplet rule, then formation of ions, all about. So this is how we done with this chapter. I hope your every concept is clear. Okay. So thank you for paying attention.